Welcome back. In this lecture, we want to learn some delta table utilities. We want to learn 2-3 utilities and some optimization in delta table. So let's start with that. Let me go to my workspace, and in my home directory, chapter 7, I have added one notebook for us to understand some delta table utilities. So let me connect to my cluster, uh, do some cleanup as usual, and then do some setup. So basically what I'm doing, I'm creating dev catalog, demo DB database. I'm reading some data from Databricks sample data set, doing some basic initial transformation, basically renaming some columns and applying some data type conversions to some of the columns, calculating some extra columns, and then writing it as a delta data set in this table. So basically I have a fire calls TBL delta table already created. So we have a delta table and we want to learn some delta table utilities with the help of this delta table as an example. So first thing, the first utility that we want to learn is vacuum utility. So what is the vacuum utility? What is the purpose of the vacuum utility? To understand that use case, let's go step by step. What is vacuum utility and why we use what vacuum utility? That's what we want to understand. When we use vacuum utility, that's what we want to understand. But for that, let's go step by step. First thing that I want to do is describe extended table. This is my delta table. I want to describe that table using describe extended. So describe and then extended and give the table name and figure out some details about the table. So I'll go down and look at the location where this table is stored. So this table is stored in the meta store root container in my storage account in my Azure account, right? And inside that container root, there is one directory automatically created by Unity Catalog. Maybe this is a directory for the database. And then inside that directory, I have a tables directory. And inside that tables directory, this is the directory for this particular table, fire calls TBL. All that is managed by Unity Catalog internally at the storage layer. So these weird directory names are there. What I want to do, I want to look at the data files for this table. I cannot access this location directly from here from my notebook without creating an external location for that. It is secured location. I cannot access it directly from here, but I can see that from my Azure account, right? I own that directory or that container in my Azure storage, so I can definitely go and look at it. So let me go to my storage account. This is the storage account where this directory is created, and in the storage account I have this meta store root container. So I'll go to container and meta store root container, and inside that we see a directory BE314. So possibly this is the one, BE314. That's the directory for maybe database or catalog. We go inside that and we have a tables directory, and inside the tables directory we see a bunch of things. So which one is my table. Let me copy the directory name from here and search for it. So this is my tables directory. That's how I could locate it. Let me go inside, and then inside I can see one delta log directory and a bunch of data files, right? These are all Parquet data files. Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 data files are created. So that's what we have. That's how my data is stored for this delta table, right? Now I have a delta table, and most likely we will be doing some transactions on that delta table as part of my project, maybe updating some records, deleting some records, merging some records, all those kind of transactions I'll be doing. So let me simulate some transactions. So I have a delete statement here. I'll copy paste. What I want to do, delete some records from this delta table, and where call date is this, right? So let me delete it. I'm going to delete some records, assuming that it is part of my project requirement on that delta table. So I've deleted 597 records. Let's do one more transaction, and this time I want to update the entire data table without any where condition. Basically what I want to do, update the delay column with an int value of the delay column. So maybe delay column is a decimal value, and I want to ignore the decimal part and update the entire table with only the integer part of it. Whatever. We have a requirement, assume that we have a requirement and we are doing some transaction on the delta table. So let's do that transaction. And once that transaction is done, I know delta table maintains a complete history of all the transactions, right? So let's describe history on that table, and hopefully I will see 3 versions. Version 0, okay, these many records are updated. Version 0 when I initially created the delta table, version 1 when I did the update, and version 2 when I did the delete. So as expected, we already learned all that. I see 3 versions of the table, right? And I also learned that in delta table, whether we do delete or we do update, it will create new data files, right? For each version, it will create some new data files with the modifications implemented for that version. So if I come here, initially I had 9 files. I did refresh, and I can see maybe some more files are there, right? So how many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So now I have 15 data files. And why 15 data files, or why more data files? Started with 9, and why we have more data files? We already learned that in the earlier lecture. Maybe delete has modified some data, so new data files are created. Update has modified some data, so new data files are created. And what is the use of these old versions? I can query my old versions, right? I can write a SQL query. I can generate reports as on some point in time, or as on some older version. So let's do an example for querying the old state of the data. So let's say this is the query. Select a star from that table, version as of 0, where call date is this. So this is the condition for my delete statement here, right? On version 0, I deleted these 597 records on the version 0, and we got version 1 created after the delete. But I want to access those deleted records again for whatever reason, for some business purpose. So I can go and query version 0 of the same table and look at those records with the where condition on call date this, right? So 597 records which I deleted earlier, here 597 records, I can still access them from the version 0, right? That's the purpose of having multiple versions or older versions. But how many versions? How long do you want to maintain all those versions of your delta table? You keep on maintaining that versions, infinite number of versions, you will end up creating infinite number of delta table files, right? Data files. It consumes space. That's a problem. Space is cost. Or there are some regulatory requirements, right? Maybe I deleted these records because of some regulatory requirement. If the older versions are still available, we can access it. But the requirement was to get rid of those records. Do not keep it in your system. So I may want to clean up my older versions. I may not want to keep them. So how do we do that? So point is straight. How do we get rid of older versions of your delta table which you don't need, right? So how do we do that? So that's where vacuum command comes in. Delta table vacuum utility is just a vacuum command. You can use that to clean up your older versions which you don't want. So how to give you a demo how it works, I want you to count the data files from the backend. So as of now I have 15 data files for this table, and then try to vacuum the table with zero retention. So let's see how the vacuum command works. This is how the vacuum command looks like. Simple, super simple. Vacuum and then tell the delta table name which you want to vacuum. This is the delta table name, and you tell retain how many hours of data you want to retain, right? And it also comes with a dry run which will not delete those old versions or old data files, but only report you that what is the what it is going to do. So let's say I want to do a dry run and understand how many data files it is going to do on this table, and I don't want to retain anything. We have 3 versions here, right? 0, 1, 2, and I don't want to retain anything. I want to vacuum the entire table. Does it mean vacuum will delete the version 2 also? No. Vacuum is to clean up older versions, but latest version must be there, right? At least one latest version must be there. So vacuum will keep the latest version and remove the older versions. Which versions to remove will be based on this retention hours. So you can specify retention hours. 0 hours means keep the latest version, remove everything. 100 hours means keep all the versions which are created in past 100 hours and remove everything else. So like that you can do. So let's try to do a dry run because it is going to remove the files. So it's always advisable to do a dry run, but it failed. Requirement failed. Are you sure you would like to vacuum files with such a low retention period? It's a weird ask, right? I want to vacuum everything, not even a second's data. Only keep the latest one, vacuum everything. 0 hour retention is a big thing to do, a big decision to do. I want to do it for demo, but we have a built-in safety check in Databricks platform for such a low retention vacuum. It will always throw you an error. Are you sure? Be double sure. Default is 168 hours. right? If you are not sure, please use the value not less than 168 hours. 168 hours, if you translate it into days, it comes around 7 days. So default retention is 7 days, which means recommendation is to keep at least 7 days data, old versions worth 7 days, and maybe older than that you can retain, uh, vacuum or clean up, and this guy will not complain. But it is giving us a warning. How do I disable that warning? Okay, fine. You are, thank you very much. You are giving me a warning. I'm not doing foolish thing. I have a purpose for doing that. I want to do it. So they also said that, okay, you can set this configuration to false and we will disable this check. So let's do that here, and maybe I can use set command to set that configuration to false. So Spark Databricks Delta retention duration check enabled, which is by default true. I want to set it to false, and try vacuuming everything with 0 retention hours. This is applicable only if your retention hours are less than 168 hours or the default 7 days. So let's try running it with a dry run. Okay, I have not executed this. So let me run this, and once it is disabled, I can try the dry run once again. Okay, so it shows 10 records here. So what it is showing, that it is going to, if you run this without dry run, if you actually run this, we will remove 10 files, right? They will remove 10 files from your data set. So let me remove this dry run from here and run the vacuum. Let's see what happens. Let's go with it. Remove the older versions. Keep only the latest version. Done, right? So let me keep the dry run here for safety, but we have done it without dry run. Now count the data files from the backend. It should have removed 10 data files. We had 15 data files earlier. If you refresh, 10 files are gone and I have only 5 data files. So my storage is cleaned up, right? Unnecessary files which I don't want to keep is cleaned up. Now, since I deleted my older version, can I run this kind of query as version as of 0? So obviously it should not work. I'm trying to access version 0, but I vacuumed version 0, version 1 both. I only have version 2. So if I try running that, I should get an error. File read exception. While reading this, that file not found, blah, blah, blah. So the advantage of having a vacuum is that you can keep cleaning up your older versions of Delta table which you don't need. A disadvantage is that once vacuumed, you cannot access the older versions. But that's the requirement in many cases. We may want to keep it for 1 month, and after that we want to clean up our older versions. So if you have that requirement, you can run vacuum commands. I hope you understand the vacuum command, its purpose and how it works. Now let's learn about the different utility, the second utility. The second utility is known as reorg. So, but to understand the reorg, let's come up with a new requirement. Let's assume that you have a requirement to remove some columns from your table. I already have a table here. A table name is fire calls TBL. It's a delta table. I want to drop some columns from this table. Can I do it? Maybe alter table statement should work. So let me copy paste alter table statement for the same. Here is the alter table statement. Alter table from dev demo db fire calls tbl drop columns, and I want to drop these 2 columns from that table. These two columns are already there in that table. I want to drop it. So alter table statement should work. Let's try it. It didn't work. A drop column is not supported for your delta table. This is a feature which is available in some new versions of the delta table. Maybe that is by default. It is not enabled for all delta tables. I have the newest version of the delta table in my environment, but by default that capability, alter table drop columns capability, is not enabled in the delta table. Why? Why it is not enabled by default? Maybe they will enable it in the future versions, but think about it. You have a delta table where your data is stored in these 5 files. Maybe these are huge files. In my example, it's not very huge. I have like maybe 100, less than 150 MB data, but you may have a huge delta table. Your data is stored in these files, so you may have a lot of data. You may have lot of data files. Alter table drop column, what does it mean? You want to remove data for 2 columns from these files, right? And you also want to drop those columns from the metadata. So table is made up of 2 parts. One is table metadata, which defines what are the columns are there in the table, and the actual data where your data is stored. So if you want to drop 2 columns completely, those 2 column names should be dropped from the metadata, so that when you do select star next time, you don't see those 2 columns. And then data for those columns should also be dropped from the table, from the data files. So there is a lot of work to do for dropping columns, which could be a very time consuming operation for very large tables, and that's why this is not by default enabled for time being, but that feature is available. So that feature is available. Dropping columns feature is available with some optimization. How to enable that optimization? You have to set these table properties on your delta table. So alter table, table name, set properties, and you have to set these 3 properties. Enable column mapping mode by name, and min reader version 2, min writer version 5. Simple. I'm hoping that these features, these properties will be enabled by default in the future versions. But let's do that, because we actually want to drop these 2 columns as part of the business requirement. So but it is not allowing me to do that. So let me alter my table, set these 2 properties, and then try to drop those columns, right? So you can set it on an existing table, no problem. So I've set that configuration, and now if I run this, it will drop those columns. But what are these properties? What it is? Enable column mapping mode by name. What it means? It is saying that, okay, we can take an optimized approach for dropping columns from an existing table, and that is drop it from metadata, remove those columns, right? But leave the data in the data files. Don't touch the data files. Leave it as it is. Data is there in those files, but we removed the metadata. So whenever we do a select star, we will select only those columns that are available in the metadata. And even if some user is trying to access those 2 columns, we will keep that in the record. We will mark those columns that these are marked for deleted. So we will not allow anyone to access those columns, right? So select supervisor district, fire prevention district from this table will not work, because the column names are marked for deletion. So that is an approach, that is an optimization they have in place and that optimization we have to enable manually. So that's what these properties are. We are enabling them manually, and once we enable them, then I can drop column. It will work like this, because what it is going to do, it's just going to mark these two columns for deleted, as deleted. It's not going to modify any of these data files and physically remove the data from these files. So let's do that, and worked like very quick, right? And if you check the history after that, because it's a delta table, it should have the history and should keep a record of everything we are doing, right? So let's do describe history on that table. You will see drop column created version 6, even set properties also created version 5, and on top of that we dropped the column, and it has recorded that supervisor district and fire prevention district, these two columns we are dropping. So that's how alter table drop column works. But let's say we have a regulatory requirement to get rid of those two columns. We are not supposed to keep those columns in our record, in our system. Because of some regulatory requirement, we need to physically remove it, which is not done from these files. If you refresh this, we still have those 5 files, because for drop column these files are not modified. Nothing happened on this file. So basically in those files, those column values are still there, but we want to get rid of it. For maybe there are two possibilities, two reasons for that. You have a compliance requirement, regulatory requirement to get rid of those fields, or those fields are unnecessarily taking storage space on your storage layer, and you want to get rid of those files permanently and save some storage space, right? So how do you do that? Maybe that's where reorg comes into play. We have a reorg tool which will look at your delta table data files, look for what all the things are marked for deletion later, and if you run the reorg, it will go and physically remove everything that was marked for deletion, right, later. So it will reorganize your data files, reorganize your data set once again, also implement some optimization maybe in the background, because it will read those files, remove the deleted columns, deleted values, column values, and rewrite those files. So but you can do it later when you have bandwidth or resources or time to do that, not as part of the project transaction. As part of the project transaction, you will do alter table, which will work like charm, like quick, and later in the background you can reorganize your tables later. So how reorganize work or reorg work? It's a simple SQL statement. Let me copy paste it so that you can learn the syntax. Simple. Reorg table name, reorg table, give the table name, apply purge. That's all. So I'm going to run this, but before running this, let's look at the data files here. I have 5 files here. Let's do the reorg, and it's going to take some time depending upon your data size. Okay, so it worked, and what it says, number of files added 4 and number of files removed 5. So what it did, these 5 files we had, which are for the latest version, and it removed those 2 columns from these 5 files. So basically these 5 files should be removed, and it has written new 4 files, and that's what it is reporting. So it took those 5 old files, removed those 2 columns in memory, and produced 4 new files without those 2 columns. That's the reorg activity. So if I refresh this, I should see 4 new files. What about these 5 files? Let's refresh it. So these 5 files are still there. They are not permanently removed. They are now not part of the latest version. So what it means, if you look at the um, version of your table once again, you will see version 7, which is created as part of the reorg. Version 6 is as part of the drop column. So version 6 also exists. Version 7 also exists, right? And that's why these 5 files are still kept there as part of the version 6 files. Where are those 4 new files that reorg has created? Maybe due to some reason how they implement, they created a directory, and in those directory they created these delta files. So maybe you can see 4 directories with some random names, and these data files are kept in the those 4 directories, right? So all 4 directories has got one file. That's what it is. Maybe for some technical reason, the new files after reorg are created into subdirectories, randomly generated subdirectories. But we get the sense, right? Reorg has marked all these files as version 6 files, and these new 4 files as version 7 files, which is created after reorg. That's what the reorg does. Ideally, if you are doing reorg, you want to physically remove those columns that were dropped. You should be doing vacuum also at some point of time. So what if I do the vacuum once again after the reorg, right? Reorg, vacuum, retention 0 hours. Let's remove the dry run and try running it. So keep the most recent version and everything else remove it. So in that case, vacuum should remove all these 5 files because these are older now. So it is running. I'll just keep this dry run here, and then we got some output here. So let's refresh this. All those files are removed, vacuumed, right? And my data files here in these directories after the reorg, those are still there, right? So all those are there, and I can see 4 directories here. So that's all about the reorg. Reorg is used to logically deleted or records or columns, things that are marked for deletion is used to physically remove them and create a new version of the data set after removing the marked for deleted things. That's what the purpose of the reorg. And usually after reorg, if you really physically want to remove your old dataset files, you should be doing a vacuum also. Now the last thing that we want to learn is optimize and zorder. So optimize is the next utility or delta table tool offered by Delta Lake, and zorder is an option which can be done after the optimize or along with the optimize. So what is optimize? The purpose of optimize is to create evenly balanced data files with respect of their size on the disk. So basically, when you are creating data, when you are ingesting data, collecting data, maybe you are collecting it in batch or you are collecting it in a streaming, you are saving data, writing data into your delta table, and there are different frequencies. Maybe every second, every minute, every 30 minutes, every hour you are ingesting, collecting data. In all that, it is very likely that you will create a weird kind of data files, because maybe you are ingesting something in streaming. Every 1 minute is your streaming trigger, and every 1 minute you are saving some data into the table, creating a small files, right? So, and we know that small files are big problems for Spark. Spark has to open too many small files, close those files. Lot of time goes in listing those files, opening those files, closing those files, which is an unnecessary activity. So it is recommended that you come up with the decent size of files. Your file should not be like 1 KB, 2 MB, 3 MB, 5 MB. Have at least a decent size of files. The recommended size is 128 MB. That's the default setting in some of these Spark configurations. So, but what if you have created your small files or uneven files in your delta table due to various reasons? Can we optimize it? That's where the optimize command comes in. So if you already have a delta table, you leave it for maybe a month or maybe a week. Let all the weird types of file sizes get created, and maybe on a regular basis, on weekly or monthly basis, you do the optimize ones to fix whatever problems you created till then. So that's where the optimize command comes in. So optimize command will recreate, read your existing data files which are not yet already optimized, and recreate evenly balanced data files with respect to file size on the disk. So that's the purpose of optimize. And z order is an option which you can use along with optimize to co-locate data by column. It's like we sometimes do our delta table or our tables partition by some column, right? Why we do that? Because we want to co-locate data for that partition into a separate directory and take the benefit of partition pruning, right? Similarly, there is an option in Databricks or delta tables. While you optimize, you may define some column. Okay, these are the columns which I'll be querying most frequently, or maybe these columns which I'll be interested, or I want my data for these columns, same value of these columns, all the records should be kept together. Since you are recreating data files, let's do that also, right? So z order is an option with the optimize command which will try to co-locate your data for the given columns while recreating those data files. So let's see how to use optimize and z order. It's a very simple SQL kind of a statement. So let me paste the code here. So what I want to do, optimize this data set and also z order by year and call date. I want to keep 2022 year data together or closer, and then maybe by call date for the entire year. By call date also I want to keep it sorted or closer together, because I know that's what my requirement is on this table. In the future we will be reading data mostly by year and call date, and I have not done partitioning on these columns, so but still I want to take some performance advantage by doing z order on this column. So that's what it will do. So before I run it, let's look at what do we have in our directory. So I have 4 data files. They are spread in some randomly named directory due to reorg. If we go to one of it, maybe file size is 45 MB for the first one. I come back, look at the second one. File size is 33 MB. Looks like almost evenly sized, 35 MB, right? But still the files are small, 30 MB, 40 MB range. Ideally they should be somewhere close to 125, 128 MB. So we have a scope for running a optimize here. So let's do the optimize and then we will see what optimize has done from the backend. So let me run it. It's gonna take some time because it will rewrite the data files after optimizing those data files. It is done. So what we see here, num files added 2. The result is 2 files out of 4, and num files removed 4. So what it has done, it has created 2 files and removed 4 files. And let's go back to our directory and see what it has done in terms of files. Okay, so I see 6 new directories now. 6 directories now. Maybe 4 were already there, 2 new directories are created. So looks like optimize is also putting data back into some randomly created subdirectories. Let's go into this. So I see one data file here which is like 35 MB. I don't know if it was there or it's a new one. Here also I see a 39 MB data file, but 4 of them were already there for the older version, reorganized data files, and 2 are optimized data files. So let's do a vacuum on that so that we remove those 4 old files. So let me do a vacuum once again. Usually after optimize you want to get rid of those small files, older version of those small files at some point of time. So you will be anyway doing vacuum. So let me do the vacuum. Okay, so that's done. Vacuum is done. Now come back here at the directory, try to validate what it has done, refresh it. Directories are still not gone. I still see 6 directories, but let's go inside this directory. There is no data file, right? So looks like files are vacuumed, but directories is still there. This is also vacuumed. So 4 empty directories I am expecting. This is there, 76 MB. So maybe this is optimized file, NP. In the NP directory I found one file. Let's go to PK directory. Here also I found maybe 90 MB, which is an optimized file. So I already found 2 optimized files in NP and PK. These 2 should be vacuumed already. So no files there. And here also no files there. So that's how vacuumed worked. Maybe it has done what we expected, vacuumed all the reorged files and kept only 2 optimized files in the data directory. We usually don't go into the data directory, do all that validations, but since we are learning and we want to make sure we are learning correct, we are validating everything that we are learning. So that's all about the utilities and optimizations on delta tables. We learned 2-3 tools, vacuum, reorg, and optimize, and also z-order. So that's all for this lecture. See you again. Keep learning and keep growing.